Welcome to the 8th episode in a series where I'm upgrading my mini-lathe. If you're a first-time viewer and are here for some brushless motor action, then head back to the start of the series. Hopefully the card for the playlist will show up here. In this episode, I'm completing the installation of the power supply onto the mini-lathe. So let's get straight to it. So the current sensing chip's finally arrived and I've created this little daughter board here. And I think I explained before, but if I didn't, my concept is not to have any 24 volts going to the main processor board. So in this case, I'm going to co-locate the current sense chip with the board here, and I'll screw it directly on here onto those two terminals, and it'll be solidly held with the shunt and won't be waving around. And I've got some cable restrainer here. So let's take a quick look at the board. On this side, there's not much to it. You can see, maybe if I zoom in there, and of course it's upside down. Texas Instruments INI 282. It provides for a 50 volts per volt measured, so 50 by amplification. And I've used a little SOP adapter board here to pin it to the back of this bit of breadboard. And you can see there I have the cable restrained so it won't create any tension on the connection there that I've made with the board. On the other side here, there's not much to it. I decided not to go with any offset, so it'll only be a positive direction measured current. So it's just the two references grounded out, so it'll be a 0 volt reference, plus and minus 5 volts. You can see the two sides here for the current sensing coming into the chip. I've got one decoupling capacitor, 0.1 microfarad surface mount chip type capacitor. Also on the output side here, I've got that 102 or the 1K resistor, just to provide a little protection. And as I've got a 0.1 microfarad capacitor on the input side of the blue pill of the STM32, that should provide a little bit of filtering on there and get rid of any high frequency stuff as well. So let me screw it on there and give you a look at how that looks. So there it is, screwed on there, and it's pretty solid and not interfering with the shunt bar itself, and there's no interference under here as well. Those two screws directly will pick up the both sides of the shunt. And I'll also Captain tape both sides as well, just to provide a little bit more protection, just to make sure nothing gets in there. And so that's it with the Captain tape on it. See, I've just wrapped it just once or twice. So here are the two parts I printed to mount the power supply. This one here is for the bottom, and this one is for the top, and it's meant to go down in here. And the way it's mounted is just below the lead screw there, and the shunt will fit in here, and the power supply goes in front of that. And this piece here goes up on the top there and has some cable management holes to allow the cables to run up through the top there. So yeah, the power supply sits on the front there, and amazingly the holes all matched up. This is the first print I did. However, this was slightly offset to the left, so that's no good. And at the bottom here, you'll notice there's this lip here, which I managed to forget. So get rid of that. And I printed 2 new parts to fix that, which is not too bad. And these 2 parts work well. Some minor modifications. You can see the old part here. I decided to save a little bit of filament. I'll chop the edges off there. But I've just moved the screw holes here a little bit. And I also changed the way that these holes here work, because there's 2 screws here, but these cable management hole on the left side here creates a weakness, so it flexes. So on the last cable management holes, I've closed them off so there's no weakness there once that's screwed down. I've also inserted all of these thread inserts on the side here. So if we look at the side here, it's like this, and the power supply sits on the front, and that gives me somewhere to screw the cover to. And in the back here I've got the inserts here to screw down the shunt. You'll see here where I've printed there's some supports, some custom supports which I made. I don't really like using the normal supports. It's a bit nasty here, but it doesn't matter, it's all hidden. And I had to cut these holes out here for the screw holes for the motor mount, but that fits straight in there. It's a good fit. And this fits on the front here just like that. And as you can see here, it provides a spacer, but it also provides a protection to stop garbage from getting in the side there as well. So I'm going to work on getting the power supply mounted and everything mounted here now. So just a quick look, I've just bolted the upper and lower mount brackets on. It's just 4 screws using the existing holes that were in the original router. And you can see the cable management there. I'll do the cabling next. You can see here the shunt mounted down there, and just drop that in here, and you can see everything sort of lines up here. So I finished the wiring that's going to sit behind the power supply here. I'll give you a quick look at that. So the mains power is coming up in here, and the earth is connected, and the earth wire is going to go up to the power supply top here, and then the power will continue along here to the switch assembly, which will be sitting on the side here, and then the power will return through the switch and fuse assembly back up here and across and into the power supply. So the 24 volts come out. Obviously the negative side just goes straight to the motor, and the positive side going through this fuse. It goes down here through the shunt and then back up behind here and around and into the motor connector. And the other connectors we have here is the opto sensor for the chuck, the RPM for the chuck, and here sitting behind there is the shunts connector, and the other connector which is hidden down under here, that's the motor compartment connector here for all of the signal control, temperature, speed and control. And then they all head straight back up here in 3 looms to the connector, so that the control panel will sit up here. So that's what's behind there. So here's what it looks like before I put the cover on. you can see that the wires come up through the cable management slots here, and just fold over the top here and it's screwed in. So the plus 24, the ground, and there's the mains voltage coming in here, and the power supply sense circuit for the controlling the fan and sensing the temperature is coming back through here, and the 5-volt rail that's generated with the buck converter is also coming back across here. So the cover just fits just nicely on top of that. In fact, it's just slightly bulging, but I think it's okay. And here it is with the cover slid on, slides on from the front and goes in. You can see it covers up those back holes quite well, and I've got that little panel down here to protect the bottom section, and some vent slots to let some air in. But most of the air will be coming in from this side here, where it's quite open, which is fine. And so yeah, the control panel will be up here on the angle, and the mains switch and fuse control box will go on here, which I'm working on now. A quick reminder of what the original control system looks like for the lathe. Basically the power switch, fuse, an indicator and a speed control here, which is just a simple pot. And in normal operation you'll be using this on and off switch to activate the lathe. Now in the new system I'll be using this controller, and it'll be a push button to start and stop when you're using the lathe. But even so, we still need a mains power switch, a fuse and an indicator to make sure that the main side of things can be immediately turned on and off. So the original fuse and the original indicator I'm going to reuse. This switch I'm not going to reuse. And obviously I can't mount this back on the lathe now that I've got the power supply on there. So what I've come up with is this sub-module which sits on the side of the power supply, and this will contain obviously the indicator and the reused fuse, which I'll wire in. And what I've decided to do is come up with an emergency stop power switch type system. So I found a couple of things in my collection which I've reused from old dismantled electronics. So here's a power switch which is rated well enough for this job, and I've got a couple of springs here. So those are the only parts that I've had to prepare, and then I 3D printed obviously this housing for the switch, which will sit in here, and I have a cover for the switch. I have the power off button and the power on button. Now to get the profile of this case, I'm sort of jumping around here a bit, I did actually print these little templates and actually mount it and make sure it fit. It actually took me 3 tries to make sure I get this right, but I could make sure the screw hole alignments were correct, because these are not elongated holes, and make sure the shape was correct. So this is a very recommended activity if you're going to print anything big like this. And this thing takes like 11 hours or something to print. It takes a long time because I'm printing it at 0.4mm layers. Yeah, I definitely recommend doing these template type printouts first before you move on to the real thing. Fortunately I only had to print this once, even though I did redesign it later. I rushed a bit and I messed up the design of these buttons a little bit the first time, so I had to print these twice, which is not too bad I guess. And also this cover was incorrect as well, so I printed it a second time. So let's have a look at how this emergency switch works. So we have this long on switch, and it's got these little nubs here on the end, and this surface here for pushing the switch basically. So it's got a lot of surface area in a line there to push the switch. And on the off side of things, again, we have the surface area to push the switch. To make sure that the off switch is always in the up position, I've decided to put in a couple of springs. So the springs mount in these holes here and slot in here. To actually mount this in here, I actually have 2 slots 90 degrees offset from 2 shorter slots, which are the main slots. So that holds the orientation. but it also captures the switch. So to insert it, goes in, and it goes quite deep, deeper than it would normally, because the switch would normally stop it from going that deep. So in this situation, I can then spin it, make sure I get it the right way around, 90 degrees, so it's free to spin there, and then push it into the slot. Now, when the switch is in place, the lowest it can ever go is about that far, and that will stop this from rotating. There's no way that it can come out or rotate, and because this slot is a short slot, it also means that the switch cannot fall out. So that's an interesting part of the design. And to capture the power switch here, I have this ledge here. Now all of this is printed without supports. This is printed this way, and these two switches are printed this way. And you know, a simple hint for anyone who's doing 3D printing for the first time is just use 45-degree angles if you're trying to use overhangs. Don't go over 45 degrees. Don't try to use curves or anything like that if you can avoid them. 45 degrees and you're going to be pretty much safe. So in this case, this can all print without supports, and obviously this can also print without supports. So these little nubs, even, for example here, they have a small 45-degree slant on them here. And even this rounding here is a 45-degree slant. So yep, all 45-degree slants, print straight up, no supports, easy as. Let's get that back in there. So let's assemble this so you can get some idea of how it works. Now you can assemble it in a couple of different orders, but I prefer to do it this way. So this switch here is just a standard switch, and it's pressure fit here. It's got these little pieces here which create pressure and stop the switch from coming out. So normally there would be a hole and you'd pop it into the hole. Obviously it's not that easy to pop it into the hole here. So what I do is I'll push it here on the angle and then spin it around, push it into the back. So now that's in there. And the next thing is I'll put the springs here, and these holes are a little bit undersized, so they do have some friction fit there, which is sort of nice. So we have the two springs in here, and now we'll install this. Now to install this, make sure these two springs are down, flat, and there you go. Nice, you have some fingernails. And once you push it across, it's going to pop into those holes. If it doesn't, you can give it a bit of a shift. And now you can see the action in action. So the switch, as I said before, cannot drop any further than there. So the nubs now lock in place, so it can't spin around. The on switch is just gravity, so gravity held down, there's no spring. And so it's not going to work that way, it has to work vertically. But the fit is loose enough so that it will move around. Obviously the nubs again stop it from falling out. So push it to switch it on, and you can see it's a very positive press there to switch it on. And then you can use a flat hand. Now it's designed so that if you use a flat hand and you push it down, this on switch does not protrude past the surface of the off switch, so you can punch it pretty much and it's going to go off, and that's for emergency sort of action. And you can see here that the off is being pushed down and the on flips up, and that's pushing the on button upwards a little bit, but it's no problem. So off, on, and the spring is keeping the off switch always up, so even when it's on or off, it will be proud and hanging up. And I think it gives some satisfaction to be able to slam the off button, so I think that works pretty good. So on, off. And then finally we have the capture plate here, which completes this structure here. And it's a good tight fit on the top here, so there's minimum gap, but I've left some gaps around here. And there you have it. So I finished the wiring for this box. It's nothing very complicated. The idea is that it has to be removable easy enough, so when disassembling or maintaining the unit you can just pop it off. So the power comes in to the switch here on these two connectors, then it's just following pretty much the original circuit. The neutral is sent up to this light indicator, and then straight out after it goes through the switch. And on the other side, the active is going through this fuse before going to the output connector and also to the light as well. So nothing complicated here. And taking a look at the actual unit here, you can see here the connectors are actually different too, which makes it a bit easier to identify. So this is going to the power supply, and this is coming from the external power cable connector basically. And the earth is wired directly to the chassis and to the power supply earthing connector. So there it is, all wired up. Should all fit in there quite nicely, I think. Can be done one-handed, so it's not too bad. Yeah, I like that. So I'll get the screws in there. So there you have it, all mounted up. Just those 3 screws. I think it's pretty solid. No way to accidentally turn it on. And if you switch it on, you can do how it comes on. Emergency stop. It takes a while for the power supply to shut down because there's no load on it. And that's a wrap for this episode. In the next episode, I'll be working on the last of the hardware, putting the control panel into a case and installing it onto the lathe. Thanks so much for watching, and if you want to like, comment or subscribe, it's always appreciated. And I hope to see you for the next episode.